Hi, welcome to my video on the real number system. Explanation of terms before we begin. Set and subset. A set refers to a group. A set of all members of a family is a group. A subset refers to a part of a group. A father is a subset of the family. Children are a subset of the family. Other subsets of the family are mother, son, daughter. So these two terms will be used in the number system. The first set of numbers is the natural numbers. The natural numbers can be referred to as the counting numbers. If you were counting the number of people in a room, you would start with 1, 2, then 3, then 4, etc. The natural numbers are 1, 2, 3, 4, 5, ... They're going on to the right to infinity. The 3 dots on the right indicate the numbers are continuing on. It is not possible to list all the natural numbers. The symbol N, capital N, denotes the set of natural numbers. N equals 1, 2, 3, 4, 5, 6. I can keep on going, but the dots indicates it's going on to the right. The circle, I will name N at the top, and I will just put 5 natural numbers inside. So this circle is representing all of the natural numbers. It's impossible to write them all down. The next set of numbers is the whole numbers. The set of whole numbers consists of the set of natural numbers and 0. The set of whole numbers are 0, 1, 2, 3, 4, 5, and 3 dots. The 3 dots on the right indicates the continuation of the numbers to infinity. The symbol W, W for H whole begins with W, so capital W represents the whole numbers. Let's classify a couple of numbers. The number 6 is a natural number, and it's a whole number. 0 is not natural, but it is whole. Note the numbers 1, 2, 3, ... are natural numbers and whole numbers. 0 is a whole number, but not a natural number. So if I put the natural numbers inside here, which I have, and put W for the whole numbers, 0 goes in the outer circle here in between. So 0 is not in the inner circle, because it's not a natural, but it's all by itself. Now, it said that N is a subset of the whole numbers, because all natural numbers are whole numbers. Notice that subset is a part of, so the natural numbers are part of the whole numbers. What whole number is not a natural number? What whole number in here, inside of this big circle, is not a natural? So you can see it's a 0, 0. It's not natural, it's a whole. Let's look at the set of integers. You've heard them before. Number 1, this opposite is -1. 2, opposite, -2. 3, opposite, -3. 0, opposite is 0. 0 is neither positive nor negative. The set of integers consists of the natural numbers, which is 1, 2, 3, 4, 5, 6, 7, so on. Their opposites, -1, -2, -3, -4, -5, so on, and 0. So to write this down, let's put 0 in the middle, 1, 2, 3, 4, ... on the right, and -1, -2, -3, -4, ... on the left. So notice the integers go to the right to infinity and to the left to infinity. And the 3 dots are on both ends because they continue on both ends. The symbol I, integer begin with I, denotes a set of integers. So if I put an I at the top of this circle, then Notice the natural numbers is inside, whole numbers are inside the integers, and 1 opposite is -1. 2, -2. 3, -3. 4, -4. 5, -5. So notice the negative numbers are outside. So the negative numbers are not natural or whole. So the natural numbers is a subset of the integers. All natural numbers are integers. The whole numbers is inside the integers, inside this outer circle. So the whole number is a subset of the integers. All whole numbers are also integers. Let's classify some numbers. 2 is natural, whole, and an integer. 0 is not natural, but it's a whole number and it's an integer. -3 is not natural, is not a whole number, but is an integer. What integers are not natural numbers or whole numbers? So if we look over here, what integers are not inside with the naturals and the whole? And you can see they are the negative numbers. The negatives, integers, are not natural or whole. Next set of numbers is the rational numbers. The set of rational numbers can be defined as A over B, where A and B are integers. B not 0. We're not allowed to have a 0 in the bottom. We'll look at that a little bit down below. The rational numbers can be fractions, positive, 0, or negatives. A half, -3/7. And you can see these are fractions. 1 3/5 is still a fraction because it's 8/5. 1 times 5 plus 3 is 8/5. 3/1. So 3 is an integer, but is a fraction. 3 is also, 3/1 could be 6/2. 0 could be 0/1. It could be 0/2. -2 could be -2/1, or double it, -4/2. So -2 and 3 and 0 can be written in fractional form. 0 cannot be 0/0. 0/0 is not defined. Let's look at that now. Here we go. So 0 divided by 0, oops, it's clear, sorry. 0 divided by 0 is, divide by 0 is an error. So you can't have 0/0 because the 0 is in the bottom. Cannot have 0 in the bottom of a fraction. And if I say 1 division 0, dividing by 0, again you can see that we will get divide by 0 says an error. So division by 0 is a no-no. The symbol rational numbers is denoted by the symbol Q, denotes the set of rational numbers. So if I put the rational numbers out in the outer circle, then I could have a -1/2. I could have a -7/4. I could have -10/3. I could have 3/5, or I could have 2 1/8, etc., etc. These are rational numbers. Notice the natural numbers, whole numbers, and integers are subsets of the rational. Because the natural, whole, and integers are inside of the rational numbers. So all natural numbers, all whole numbers, all integers are rational. Let's classify some numbers. 0, not natural. Whole, integer, is rational because it can be a fraction. 2/7, not natural, not whole, not an integer, but a fraction. 9 is understood to be 9/1, so it's not a natural, not a whole, not an integer, but is rational. -4, -4/1 is not a natural, is not a whole, it's an integer, and it's a rational. -13/10 not natural, not whole, not an integer, but is rational. So rational numbers are fractions. Nope. There's another way to define a rational number. A number that can be expressed as a terminating or repeating decimal is a rational number. So let's look at terminating and repeating. Notice 1.2 is terminating, it's stopped, and it's not repeating. 6 is terminating, but it's not repeating. So it's terminating or repeating I'm looking at now. Notice 7 is repeating here, so it's not terminating, repeating. Notice that 0.1616, the 16 is repeating, not terminating. Notice that this is not going on, so it's terminating. 48.93 is terminating, not repeating. And this one, I look at it, I see a 572 is repeating, is not terminating. Notice another way to write a repeating decimal is to put a bar above the digits that are repeating. 92 is repeating, so it's not terminating, repeating. We can go back here and look and say that's 3.7 repeating. That's 0.16 repeating. This one could be 2.572 repeating if you want to put the bar in. Practice, work them out. Here we go. 4 is terminating. It's not repeating, but it's terminating or repeating. It's rational. No, it's neither. 0.666 is repeating, is not terminating, is repeating, is rational, so it's not neither. 1.43289, notice it's not terminating, it's not repeating, so if it's not repeating or terminating, then it's not rational. Oh, I see a mistake here. This one is not terminating, my mistake right here. This is not terminating. Just noticed it. So this is not terminating, not repeating, not rational, so it's neither. 30.21414 is not terminating, it's repeating. If it's repeating or terminating, is rational, so it's not neither. 21.8 is terminating, so it's not repeating. So it's because it's terminating, it's rational, and it's not neither. It's rational. 7.93 is not terminating, it's repeating, rational, and it's not neither. 610231 is not terminating, it's not repeating, so if it's not either one of those, it can't be rational, so it has to be neither. 9/2 is the same as 4.5 or 4 1/2, so it's terminating, not repeating, but it's still rational, and it's not neither. Next set of numbers is the irrational numbers. The set of irrational numbers can be expressed as a terminating or repeating, cannot be expressed as, notice the word not. So terminating and repeating decimal is rational. Irrational means not. So irrational numbers are not repeating or terminating. The symbol Q with a bar. Now, different books and different teachers might have different symbols for these. So Q with a bar denotes the irrational numbers. The irrational numbers, notice this is not repeating, it's not terminating. Notice this one, 3 dots, so it's not terminating, but it doesn't repeat, so it's irrational. Again, 6, 5, 4, 3, 2. The 3 dots indicate it go on, but there's no repeating. 3 dots says it goes on, so it's irrational. So there's no pattern, no repeating. Now, let's look at the square root of 2 on the calculator to show you what's... Square root of 2 is an irrational number. So let me do, the square root of 2. and show you. Notice, square root of 2 is 1, 4, 1, 4, 2, 1, 3, 5, 6, 2. No pattern, and it's not terminating, it's not repeating, so it's an irrational number. The calculator can only display so many digits. The square root of 6 is 2.449489743, and you can see that it's not terminating or repeating, so it's irrational. And pi on the calculator, which is right here, if I hit pi, that's the famous number called 3.141592654, not repeating, not terminating, so it's irrational. So if a number is not repeating or terminating, it's irrational. But notice that the square root of 4 is 2, so that terminates. The square root of 100 is 10, that terminates. The square root of 1/9 is 1/3, because 1/3 times 1/3 gives you 1/9. So the square root of 1 is 1, square root of 9 is 3. So even though I got a root here, like these, but this simplifies to a 2, so that's terminating. It's rational. So note now that if this is the rational numbers over here, then they're not that, so it's a completely different circle, and you have to mark Q with a bar on it. And we put the root 2, the root 6, we put pi, we put root 7.1, square root of 10.642. So notice, do a calculator on them, you get no repeating, no terminating. Let's classify some numbers. 2 over 11, not rational. Sorry, not natural, not whole, not an integer, rational number, and it's not irrational. Negative 9 is not natural, is not whole, it's an integer. Integers are rational, but it's not irrational. 3.77 is not natural, whole, integer, but it's repeating, so it's irrational, and it's not irrational. 0 is not natural, but it's a whole, it's an integer, it's irrational, because it can be a fraction, but it's not irrational. 1.6782 ... It's not natural, not whole, not an integer. It's not repeating or terminating, so it's not irrational, but it is irrational. And the last set that everything is made of is called a set of real numbers. The set of real numbers consists of the set of rational numbers and the set of irrational numbers. So if we put the rationals and the irrationals together, you get all the numbers. And we say, in that case, we say, sometimes when we draw a number line, and we put 0, 1, 2, 3, and -1, -2. So all the real numbers are on this number line somewhere. The symbol R denotes a set of real numbers. So here's the rational numbers over here. Irrational, sorry. And you got the root 2, the root 6, the root 7, the root of 2.4, etc., etc. But the real numbers is all of them. So notice that in the box we have all the circles. So the real numbers has all the irrationals and the rationals. So notice that all of the numbers that we talked about, the naturals, the whole, the integers, the rationals, the irrationals, they're subsets of R. So all naturals, wholes, integers, rationals, and irrationals are real. Again, the real numbers is all of them. So all the other sets are subsets. They all are reals. Let's classify 1/4, not natural, not whole, not an integer. Rational is not irrational, but it's a real. 10 is a natural number, whole number, integer, rational, not irrational, but is real. 7.134612, nothing repeating, so it's not natural, not whole, not an integer. It's not rational, but it's an irrational. And irrational numbers are real numbers. 0 is not natural. It is a whole, it is an integer. It is rational. It's not irrational. Because it terminates. And it's real. So decimal 67474. Notice it's repeating, so it's not natural, not whole, not an integer. It's a repeating, so it's irrational. It's not irrational because it repeats, but it is real. Root 9 is a 3. So 3 is natural, whole, integer, rational, but it's not irrational, but it's real. Pi over 2 is the same as pi. So pi over 2, let's have a look at that. So we take pi and divide it by 2. What happens? Well, if a number is irrational, dividing by 2 still has it irrational. So notice 15707963327 is not repeating, not terminating, so it's irrational. So it's not a natural, whole, integer, or rational, but is real. Root 7 is the square root of 7. I can't simplify it. Square root of 7 is, and we see that it, even though it has a 1, 1, it's still, now this is one that could mix you up, so you got to be careful. The square root of 7 can't become a 1 or 2 or a 3 or a 4. And another way to look at it is that you got a 0, 1, 2, 3 on your number line. So the root of 9 is a 3. The root of 4 is a 2. So root 7, I can't simplify it to a good number like a fraction. So it's irrational. So it's not natural, not whole, not an integer. It's not rational. It's an irrational number and is real. So now we come to the final part. Summarize it all. We have the natural numbers. We have the whole numbers. We have the integers. We have the rationals. We have the irrationals. And all of them together make up the reals. So again, natural numbers 1, 2, 3, 4. Whole numbers is 0 with the naturals. Integers are the negatives of the natural numbers. -2, -3, -4, 3, 4. The rational numbers are fractions or repeating decimals, so 1/2, 4/7, 1.666, or you can see you can have a negative 7/8, etc., etc. Irrationals are square roots that can't be simplified. Now square root of 111, square root of 8.64, etc. And the real numbers make all of them. Now let's have a bit of fun. See if you can, anything that's inside of the other one is a subset. So the natural numbers are a part of the whole numbers, etc., integers, rationals. But the irrationals and the rationals are two completely different circles. So they're never together. And the real numbers is all of them. So let's go through and have a bit of fun. Let's see if we can place the correct letter in here. Never, always, sometimes, all, but one case. An integer is a rational number. So an integer is right here. So is it an integer? Is an integer a rational number? Well, every integers are inside the rationals, so it's the integers are always a rational number. So B for always. A whole number is a natural number. No, it's a whole number is what? The natural number, but it's not 0. It's all but one case. So 0 is the only whole number that's not natural. A real number is a rational number. A real number is irrational. Well, there are irrationals that are real. So real numbers are made up of rationals and irrationals. So real numbers rational is sometimes C. Some of the real numbers are rational, but not all of them. An integer is an irrational number. An integer is in this set of rationals. Irrationals are here, so you can see that that would be an A, never. A rational number is an integer. A rational number is right here in this set. So irrational numbers are out here, but the integers are inside. So a half is not an integer. So there are rational numbers which are fractions that are not integers. So that's a sometimes. A rational number is sometimes an integer because there are fractions that are not integers. Irrational number is a real number. An irrational number, which is here, is a real, always. All of these are reals because they're a subset. They're always. A natural number is an integer. A natural number is inside of the integers. So all of these are in here. So natural numbers always be. A rational number is an irrational number is an irrational number. A rational number is an irrational number, and you can see they're not in common, so it's a never. A whole number is an integer. A whole number is inside of the integer. So all of these whole numbers, all the naturals, are integers, and that's always. Whole numbers are always integers. So always is a B. That takes us through the set of numbers. Hope you enjoyed my video, but don't forget to click on the like button, the subscribe button, the notification when I do more videos, and write a comment how you feel about it. And if you wish, you can visit my website at www.mathfullyexplained.com. There you'll find information about me, my degrees, my teaching experience, the videos. In that, I write out I teach a certain way to make sure students understand. So I'm employing that in my videos, repeat, doing problems, etc., etc. And there are topics that I've already completed that I have up on YouTube. They're in black font. And there's also topics that I have to complete, which are in red font. But that'll take a while, so hope you enjoyed my video. Thank you very much. Bye-bye.